What's going on YouTube? This is a rather lengthy 4-part series in which I attempt to try to repair, overhaul, and modify this 74 Fender Twin Reverb. In the last video, I attempted to try to explain how to measure and modify bias and cathode and grid biased amps. I also modified the circuitry to allow the bias to be changed much more easily by adding a bias pot. In this video, we're going to be installing 1 ohm resistors to the cathodes of the power tubes to make measuring the current through the tubes much easier. I'm going to present a new method for setting the bias, a new equation. We're going to encounter and fix an issue that prevented the power tubes from biasing to their potential, which will end up fixing our low volume early breakup issue. I'm also going to address the speaker cabinet and the speaker configuration. I'm also going to attempt to try to fix an intermittent static sort of zapping sound that I'm hearing in the amp. Alright, next step is we'll desolder the ground connections to the cathodes. We got one here, 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 and right there. So once we get those cleaned up, I'll disconnect this lead and I'll attach those 1 ohm resistors. That'll allow me to calculate current much easier. So I've just gotten the new 1 ohm resistors attached to the cathode of each tube. They're 2 watt resistors. And the main reason we've done this is if we look at our equation from earlier, the way that we got plate current was that we needed a voltage drop and a resistance to do that calculation. Since these are 1 ohm resistors, all we have to do is put a multimeter lead on that resistor and set our multimeter to millivolts. Since it's a 1 ohm resistor, that directly equates to milliamp. So we could actually measure in real time the amount of current going through each one of these tubes. And so that takes away a lot of math and a lot of frustration. So I'm going to go ahead and demonstrate that now. Alright, so I've got the positive leads of 2 different multimeters attached directly to the cathode resistor of the outermost set of tubes. We'll look at the multimeters here, and they're settling down to, looks like 13 millivolts and then 21 millivolts, and you can see that there's quite a bit of mismatch of current going through these old tubes. But what's good about this is that the equation is somewhat simplified. So I'm going to present a different method of how to calculate bias on this amp now that we have these 1 ohm resistors installed. So I'm going to write those 2 values down, check the other side, and then we'll go through this new set of math to calculate what our target bias should be. Alright, I have my leads connected to the 1 ohm resistors of the innermost tube set. Our figures have settled down to around 12.2 and 7.2, so I'm going to write those down. And what I'll most likely do is I'll take a look and see if there's any configuration that I can put these tubes in, or let's say that the hottermost tubes I can group to one side and then use my balance adjustment, my balance pot up here to kind of even out the current flow for each side of these tube sets. It'd just be a good idea to kind of have them run as evenly as possible. So after reviewing the current of each output tube, I think they're probably about in as best configuration as possible, the top set of tubes. Unfortunately, that one tube at 21 milliamps kind of throws a wrench in the engine. I would like for it to be a little bit more even with the others, but I can bring the bias down a little bit on that side to kind of compensate for the 12.3 and the 7.2. So I might try that. Now, with all being said, you know, I know that a lot of times the older tubes are preferred, but these, I have no idea how long the previous owner allowed these tubes to red plate for. There's slight damage on the tubes anyway from visual inspection. I will recommend to the customer, I would like to see a new set of tubes in here, and I actually threw a known good 6L6 GC tube in here, and I'll throw that one in real quick and we can take a look at the current of that. So I've got a JJ Electronics 6L6 tube. We'll kind of pop that in to see what kind of current we can get out of this thing. Alright, so I've got the JJ in the innermost tube socket, and I'm monitoring that with the mass deck. At this point, we're at 10.6 or 10.5, but luckily now with the modification of this bias resistor, I can begin to turn this. And I think before, I think it was almost all the way up. I think the maximum value we got was 21 with this, so I'll continue to turn it up and we'll take a look at just the JJ tube. So we can keep going. See if I can max this out. Alright, so we've hit the end of it and I'm able to get up to 40 milliamps of current with that new JJ Electronics tube. So I'm thinking if we put a whole new batch in here, we can get this guy to liven up quite a bit. Alright, so now that we can directly observe plate current of each individual tube by monitoring the 1 ohm resistors that we installed, we're presented with this new equation of how to calculate bias and actually gather the figures needed to get a target value. So to run through this equation, you would just enter whatever your maximum plate dissipation is for whatever tubes you're working with. You divide that by whatever plate voltage that tube is seeing. You would then times that by whatever plate dissipation you're actually going after. So if you want 70% maximum dissipation, you would times that by 0.7 or 0.5 if you're looking for 50%. You times that number by 1,000 and that will give you your desired current in milliamps. Now, since we can directly monitor our milliamp, now that we have the new 1 ohm resistors installed and we can adjust it on the fly, it makes biasing this amp a much easier of a procedure. So we've kind of got to mock up values of what might be seen in a typical amp. So let's say I'm working with 6L6 GCs. The maximum plate dissipation of that is 30 watts. The plate voltage on my outermost tube is 395.8 volts. Let's say I want to go for 50% dissipation. I would times 30 divided by 395.8. I would times that by 0.5 times 1,000. That gives me a target value of 37.89 milliamps. I'll actually demonstrate that how easy that is to dial in now. So we're back on the JJ electronic tube on the innermost tube socket. Right now bias is at 17.4 milliamps, so we'll come in here and we'll adjust this bias pot until it reaches 37.89. See if I can get my probe in there. There we go. So we'll turn it up. And I'm just turning. Oops. Went past it, so we'll come back down. So this would provide to me 50% dissipation on this tube, and with this bias pot, I bet you I can get right on it if I really wanted to. Anyway, that's close enough. So yeah, super easy now. There's also another way you can calculate this. You just really need the plate voltage, and I'll show you that method as well. Our tube bias calculator online. 6L6, 30 watt maximum plate dissipation, and we see that figure here. 50%. I think I had 37.89, so it's pretty close. So you can quickly find your target values for whatever current you're looking for, and easily adjust that if you have an adjustable bias on your amp. Now that the modifications are done with the bias circuit and the addition of the resistors to the cathodes of the tubes, I'm going to do a sound test and attempt to bias this, and we'll kind of see what kind of current we can get out of the original tubes that were in it, and what it sounds like. So I've got the amp warmed up and on. I've got the master volume all the way up, and I think I'm going into the vibrato channel, and I've got the volume at about, I don't know, it looks to be about 3. I've got one multimeter. I don't know if you can see this or not. I've got one multimeter hooked to the innermost set of tube sets to monitor the current, and the fluke on the outside set of tubes to monitor the current on that as well. Right now I have the bias pot providing the maximum amount of bias to begin with, and it looks like we're running about 2 milliamps per side here, roughly, and we'll give that a listen. So I don't know how well the audio is coming through on the camera here. It does not sound good at all. It sounds very sterile, very weak, and it's breaking up extremely early. So I'm going to raise the bias up to see what kind of effect that has. All right, I'm going to start bringing the bias up slowly. So right now, getting right about 12 milliamps on the left side, 10 on the right on the inner. I'm going to go ahead and max this guy out. So right now this set of tubes, well, this outer tube specifically, I'm running about 28 millivolts, and this innermost tube I'm actually running at around 8.7. So what I'm going to do is I'm actually going to not use the bias adjustment, but I'm actually going to use the balance adjustment to try to compensate for the difference there. So I'm running actually pretty close now. I'm at 15.5 on the innermost tube, and I'm at 15.8 on the outermost tube. Now we are still, and I've got the bias adjustment cranked all the way up, providing the least amount of negative voltage, which equates to a higher bias for these tubes, and I'm still only getting around 15 millivolts in it. Now, with that being said, I can just hear. I've already heard an increase in volume, just the noise floor, the static and stuff. That's come up quite a bit. So let's see what this sounds like. So it does sound significantly better. I might mess with the EQ a little bit and keep playing around a little bit just to kind of see if it's in the ballpark of what I think this amp is capable of. Alright, the new bias setting did help it significantly. It sounds a lot more full. It sounds stronger than the initial where we began with our bias setting. It still feels a little weak to me, and we are only at 15 millivolts on the tubes, and by my calculations, even at 50% dissipation, I should be expecting to see somewhere around the ballpark of 37.9 or 40 milliamps of current through these tubes. So right now, I think this thing's just biased still extremely cold. So what I think I'm going to try to do is install a temporary set of working 6L6s to see what kind of current we can get out of it, and to see what that sounds like. I wouldn't be surprised at all if the red plating damaged the tubes in there, and so we're going to put these guys in to see what we're kind of looking at with a newer set of tubes. And I've already ordered a new set for this for the customer. So, but I don't have them in yet. So we'll use these temporary tubes to kind of do a sound test with, and to see what kind of bias adjustment we can get out of it. All right, so I got a standby set of working 6L6 tubes currently installed. We're kind of in the same spot we were before. The bias is as low as it'll go, providing the most amount of negative voltage to the grid. So once again, I'm on 3 with the new, working 6L6s. So we are getting not even 1 millivolt per tube at this point, so it obviously sounds very, very sterile. So I'm going to increase the bias on this by reducing negative voltage. I can hear the hum level increase in volume. So if we remember, what was it, 37 millivolts at 50% dissipation. Alright, so I'm actually maxed out on that bias pot that we installed earlier. We'll give that a shot. And that's much better. Here on the outermost tube, that's one of the JJs. We're at 39. And on the innermost tube, we're at unfortunately 18. And so once again, we'll use the balance pot to try to level them out. So we're right about 27 on each side. So we'll give that another listen. Sounding pretty good. We're gonna crank this up. I was at, I think, 3. We'll do 6. See what that sounds like. Definitely sounding better. We'll have a little fun. Let's go to, I don't know, 9. So it's much more powerful. Again, these were old 6L6s I happen to have. I'd like to get, like I said, I got some new ones on the way. So once I receive them, I will install them and see what kind of current I can get out of them, and actually properly bias this thing. I am a little concerned that I'm not getting, I'm not able to get up. I'm still not even at 50% dissipation. We're off quite a good deal from the original resistor. I know that that's somewhat dependent on the individual tube, but I'm really not anywhere even in the ballpark. And I should be. So I figured we'd take a break from actually working on the amp for a second, kind of go towards the cabinet and talk about what we're planning on doing. After doing some further research, this is a JBL, looks like D130F. It's a 15-inch speaker, and from what I understand, it's actually rather desirable. Looking online, like used, you're almost at the $300 mark. With this, then between $200 and $300. Now, with everything being said, as you saw in the earlier clip, this amp, the cabinet was designed for 2 12-inch speakers, and it looked like somebody had installed this. It's the way it looked. Most of the speaker, I want to say, was the wood in the cabinet was blocking most of the speaker, which doesn't make a lot of sense for me to keep this in there. I think we would have to do some more modification to the cabinet to accommodate the speaker. So that's one reason why I opted to put the 212s in there. Again, I'm going to try to get the customer to do an upgrade rather than those stock speakers that came out of those hot rods. I'd like to see some nice custom speakers in there as well. Looking at the other side of the speaker here, there is some signs of damage. I want to say it's kind of hard to tell. I can't tell if this was an attempted repair or if this is just damage, but you can go right through there. I think there's a couple spots around here with some damage. Now this stuff, it can be repaired, but again, if we're gonna do this, if we're gonna put this speaker in there, I would want to actually modify that cabinet to accommodate the entirety of the speaker instead of just kind of throwing it in there. Right now I've been using the Mojo Tone 112 cab that I had when I built one of my older amps, and usually I like to run a Warehouse Veteran 30 in there, but I actually don't remember what I did with it. Oh, I remember. I moved from a head from the amp that I built to a combo cab, and I took it out of this and put it into that guy over there. But anyway, so right now in its place I've got an old Fender speaker from a hot rod that was modded. It was actually this guy right here, and this has kind of been my test cabinet that I've been using. I actually had another one of those speakers out of that Blues Junior up there. These both have Veteran 30s in them as well, and so I threw that stock Fender speaker into the twin cabinet, and I think I'm going to take this one out and install it in the other spot there. I would recommend a speaker upgrade than these stock Fenders personally, but I'd like to get them in just a working ballpark with this amp at this point. So I think this is going to be a temporary band-aid fix unless he decides to keep them, or if he wants to upgrade, we can do that as well. So I'm going to pop this guy into there, wire them up, and hear what this sounds like with 212s. So now I have both speakers installed and tightened down. The next thing we'll do is get these guys wired up and fired up and see how it sounds. So the original connector doesn't have the speaker connectors on them like these do, so I'm gonna have to solder these in to one of the pins on here. So we'll do that real quick, and we'll plug it in and we'll give it a sound test. Since the chassis is still on the workbench, we're still going to use this lead out to the cabinet here. Since it's going male to male, from there to here, I'm going to temporarily use this a female to female adapter to do some quick tests. I wouldn't recommend this as a permanent installation, but I think for the brief amount of time we're going to be doing it, I think it would be okay. So I've just gone through and done somewhat of an extensive sound test. I'm not entirely confident that this amp is up to snuff yet. Fully aware that we're not even close to 50% dissipation at this point. And what I'm hoping is that, see, what I'm getting is it's breaking up much too early, and I think that's a result of the tubes being biased too cold at this point still. So what we're going to do is we're going to kind of backtrack a little bit, I think, do a little bit of experimentation. What I'm going to do is raise the resistance value of that bias resistor. I think there's a 10K in it now. I've got an assortment of resistors. I'm going to experiment with that to see if I can get this to clean up a little bit. Another thing that I'm noticing is that it sounds like this amp is too quiet for what it is. Usually any amp that I've ever owned or played, I could very easily turn it up to the point of it being uncomfortably loud. So at this, I can have this thing cranked, and it sounds like it's about half as loud as it should be. So I'm going to do a little bit of experimentation. We're going to replace that resistor and check some current in the tubes and see what kind of results that gives us. What I've done temporarily is I've tacked in a 1.5K resistor. So I've reduced the value of that resistor, which has enabled me to get in the ballpark of what I guess this amp should be roughly biased at. So I've got a little bit of flexibility, more flexibility at this point, and I've been playing on it with this new configuration with the resistor. I think it sounds better. I am getting somewhat of some strange overtones with certain notes, and it is kind of breaking up. I still prematurely. So it's been a couple weeks since I've last touched the amp. I've actually had a vacation, which really helped get me away from this project for a second. I was hoping that this was going to be just a quick fix, and it's looking like it's going to be giving me a little bit more trouble than that. So I was hoping to avoid having to really get in here and check every single connection to look for cracks, check every single voltage in this thing, and things like that. So but I think we're just going to have to get in there and really do a thorough job on this. I am still getting a low volume out of the amp, and it's looking like I've been trying to compensate with the bias with that problem still present. And so I think I'm going to backtrack a little bit. I'm going to try to get that bias resistor value closer back to Fender specs and address the issue, and then kind of go from there. So at this point, I know it's kind of dark, I do have 4 new 6L6s in there. I have played the amp. I think it does sound a little bit better. I am losing a little bit of those weird overtones and stuff like that, but I don't think that's what was causing it initially. So at this point, before I start going through really with a fine-tooth comb, I'm going to start with the easiest things that kind of go wrong, and that of course is the actual tube. So we were dealing with these old tubes that were in there originally, and I don't have a tube tester, and so I think we're gonna just replace them all just to make sure that we're hopefully dealing with working tubes. You can get bad tubes out of the box, but we're going to take a chance and just replace them all and see if that fixes any of the low volume issue. If it doesn't, then we're going to have to really get in there with, like I said, with a fine-tooth comb to kind of see what's going on. So I'm going to install these real quick and do a sound test and see if anything changes. For some reason, I don't think anything's going to change. I think there's an issue in here somewhere that we're going to have to find. So that's where we're at. We're going to install these, and I'll check back in here in a second. Just got the new preamp, phase inverter, reverb tubes all installed. I don't know if you guys can see that. These are all new JJs. I'm still getting low volume and early breakup, so I think we're going to have to kind of branch out and start looking for other culprits that may be responsible for causing this issue. So I finally have some good news to report. As you may have guessed, I have found the culprit for the low volume early breakup issue. It was the coupling caps going to the output tubes. So I'm able to get much more life out of this amp now. It's a whole lot more punchy, and I think I don't remember where my last bias setting was, but I've got it at, let's see here, right now I think I've got it at idle at, I think it was what was it, 60%, around 60% dissipation, at least on one of the tubes there. But really pleased with this thing. Just came to life with the swap of those capacitors. So I think at this point I'm going to kind of backtrack a little with this bias circuit. I think I'm going to try to experiment and put the old bias resistor back in. All right, so I got the master volume all the way up. I think we're at 3 again. The leads sound fine. I think what I was experiencing last time was just really farting out with really staccato, chunky, big fat chords, and now I mean they're as clean as can be. So I'm pretty happy with that. See, and even at this point, it's getting pretty loud. I was able to go to 9 before and still have my hearing. At this point, it looks like I'm on 4, and this thing is just screaming at me. So really pleased to have found that bug finally. So that's where we're at. I think at this point, I've got a 1500 ohm resistor temporarily installed into the bias circuit, providing my bias voltage. At this point, I think with the addition of the new coupling caps, I think it's extended my bias range here, so I'm actually able to get well above maximum dissipation of these 6L6GCs, in which case there's no need for me to go that high. And so I think I'm going to increase the resistance value closer to that of what was on the schematic, just to see kind of the range that I can get. There's no reason for me to go over 100 millivolts on this. So we're gonna experiment, change some resistors around, and kind of go from there. So I've gone ahead and reinstalled the 10,000 ohm resistor in the bias circuit. There's just not a need for a 1.5K anymore now that the coupling caps have been replaced, and the bias circuit is operating closer to normal. So I think what we're going to do is try to bias this. I've got 439 volts on my plates, and with the 6L6GC selected, and then I think I'm going to start out probably at the 60% range of max dissipation, and see what that sounds like, and kind of go from there. So we've got a lead connected to one of the 1 ohm resistors to chassis, and I'm reading in millivolts now. The amp is on and standby is off. So we're gonna see if we can't get that up to 41. So we'll try to get that dialed in real quick. All right, I'm starting on the outermost tube here. So like I said, we're right around 16.8. So we're going up around 22, 24, 30, 39, 40.5. We're looking for 41. Again, with this multi-turn pot, I bet you I can get right on it. We're at 40, roughly 41 right there. Actually, it's 41 on the dot millivolts. We're going to move this to the second tube here. We're running at 42. That's pretty close. Let's go to the other tube set. We're at 41.6, and our most innermost tube 41.7. So I'm actually happy with that. I don't think I'm going to use the balance pot at all, since we're running fairly reasonably close. So I think I'm happy with that. So yeah, we just got to track down a couple more gremlins, and that should almost be a wrap on this. I will mention I will play through the amplifier. I will listen to see if I like where the bias is set. This is just a starting spot, so that bias may change. Like I said, I've got, you know, we can run it cool, average, we can kind of push it a little bit. So really anywhere from 34 to 47 I'd be comfortable with setting. So it's just all going to depend on kind of what my ears are telling me where I kind of like it on this amp. So it is subject to change, but yeah, you can kind of experiment a little bit within these parameters and you feel confident that you're not going to blow anything up. So like I was saying, we do have some other gremlins in here. I do have the amp on now. It's actually running pretty quiet with the volume down, but when I'm playing, I'm getting some sort of arcing, zapping sounds. And so I'm going to do a little bit more research as far as what that could be. I know faulty ground connections is one of the culprits I think I've come across. So I'm going to go through this thing and see if I can't find any bad connections, and see if I can get rid of that zap. I think it's also, and I've kind of put the cart before the horse here. I kind of dove in. I intend to take some contact cleaner to the underside and to the tube pins there, and retension them as all as well. So it's kind of a tedious process, as well as kind of going through here. I've already gone through it kind of once, a quick glance over everything. I didn't see anything. The only thing I really did see was that ground connection there. That looks a little, see if I can get more light on it. That looks a little fishy to me. You guys probably just heard a little bit of that zapping noise was starting to come through, but I'm getting it on certain notes. And I got a feeling that has to do with the filter capacitor changes there. So I'm going to flip this guy over, and again, it's going to be a tedious process, but I'm going to flip this guy over, recheck all my solder connections for the cap job that was done, and if anything needs to be reflowed, I'll go ahead and do that. But the contact cleaner and the retensioning, I'm not really looking forward to, but it is what it is to find, hopefully get this zap kind of squirrely sound to go away. And I think before I flip this guy over, I'm going to go ahead and, let's see if I can get some more light on it. I'm going to go ahead and reflow this solder connection here. It looks like there might be a crack kind of where it meets. So we're going to do that real quick and do some sound tests and see if that goes away. And hopefully if that takes care of it, I won't have to mess with it too much. But I think I'm still going to do the clean out the sockets and stuff. So fingers crossed. So I'm going to try to give you an example of that zapping noise that I'm hearing. If I'm going to just play open notes and see if I can get it to happen here. So as you can tell, it's a little fuzzy, so I've gone ahead and reflowed that one ground connection, so we're going to continue on hunting to see what else we can find in here. So just got all the tubes pulled. I'm going to be using Deoxit, the D5. I've used this stuff before with connections, any dirty connections, scratching, you have an input jacks and stuff. This stuff has done a really good job in the past for me. We're just going to squirt a very, very small amount in each one of the tube sockets, and then we'll take the tube and insert it in the socket, kind of wiggle it around 3 or 4 times, and after that we'll let it dry, and before we'll power on. While I'm here, I did pull this cover off. All the connections, double checking, I think look good. I'm gonna go ahead and reflow them just in case, to see if I can get that crackling sound to go away. After that, I'm gonna really try to closely examine the tube sockets to see if I can get some of these pins retensioned as well. So all the connections with the filter capacitors have been reflowed. All the tube sockets have been cleaned, and any of the pins that looked like they needed to be retensioned have been retensioned. So I think at this point we'll flip her over and see if that took care of our kind of static crackle sound. Unfortunately, the static was still present. However, I do have some good news, is that I found out what it is. It was actually this. It's how I have it coming out of the amp into this female to female connector. I don't know if I can replicate it. Right there. I've used a little bit more of the deoxit on actually this whole connector here, and as you can hear now, it is about as clean as you can get. So I'm happy to finally found out where that static was coming from. I know a lot of times that can originate in the amplifier, and luckily it didn't take me that long to just check the simple stuff first, so I'm glad I kind of found that. So a bit of an update. I've actually got the amp chassis off the cradle here. I was suspecting that the crackling noise I was experiencing was because of the female to female connector. After fiddling with that for a while, I thought that had taken care of it. After further testing, it looks like it did come back. So what I did was actually try to remove that connection, that female to female connector. See if I can get some light on this. And actually just bring the chassis down here. I got it kind of propped up on an old toolbox to make sure the tubes don't hit the floor. And so I hooked it directly up to the amp, the speakers directly up to the amp, to take that out of the connector out of the equation, and I was still getting that static. Now, however, when I played the amp, being pretty close to it, it was kind of hard to hear, but after further listening, the crackling wasn't actually coming through this right speaker. It was only present in the left speaker. So I started to kind of look at these connections here, and they're connected correctly. However, with these clips, they're super loose. Sorry, I'm trying to hold a light with my mouth. You can see how easily I kind of just pop that up there, and you can hear that kind of crackle. it's just super loose. And so I put a bit of pressure on that connection there, and I swear again, for the life of me, I'm not getting that crackle anymore. So I'm thinking it's this shoddy connection here. Usually we'll solder these guys in, however I just put it in there just as a temporary fix, but I think for final delivery we'll solder those in there just to make sure there's a good connection. But I think again we found that gremlin at least. So once again I think I'm happy until it comes back or something, then we'll kind of take it again from there. So just as a sound test, we'll see if that crackles. This thing's so loud, it vibrates my shelves and stuff like that, so I got a lot of kind of buzz, but and this thing's super loud now. I think it's only on 3. Not getting that crackle, which I'm pretty happy about. So once again we'll move forward and see what other troubles we can get into. I'm actually kind of in a position now where I can actually finally just sit back and kind of enjoy playing the amp. And so I think I need to make the decision, do I want to do anything else to this amp? The only other thing I might want to do is to take out the master volume circuit and maybe convert that into a negative feedback control. And I think at that point I might actually be able to start wrapping this up. So I'm going to make some decisions, and we'll check back in here in a little bit. So I think we'll stop part 3 here. In this video we installed 1 ohm resistors to the cathodes of the power tubes to allow measuring current and setting bias, a much easier process. We've presented a new equation for setting the bias. We finally fixed the low volume early breakup issue, and we've addressed the speaker cabinet and the speaker configuration, and we finally fixed that static zapping sound as well. In part 4 we're going to do some modifications to the master volume control. I'm going to attempt to try to explain how the push-pull boost system works. We're going to remove the master volume pot and replace it with a negative feedback control. I'm also going to attempt to explain how negative feedback works, how a potentiometer works, and we're going to do a little bit of oscilloscope work as well. So if you've made it this far, I sincerely appreciate it, and I hope to see you in part 4.